good day for our class, our workshop. We have two systems for this workshop. We have the online system for workshop and on-site system for workshop. Then today, very grateful, we invite the professor from south of Thailand. The same, what is it? Like a relative between of us, very close, because the professor
Paramin
and Professor
M. Yes, that's the easy call for อาจารย์ M and อาจารย์ Jazz.
Those of them come from the South Thailand, from the what's the name?
Prince of
Songkhla. Prince of Songkhla University. Okay, very grateful today to have the workshop together today. Those of them is very expert, very keen in the STATA and MATLAB for machine learning, for STATA for social statistics analysis. I think it's very useful if we have time to study together. This time, good time for those of professor over here. Can start.
Yes. Okay, let me say hi for everybody again, and can I introduce myself? I mean, I just want to introduce myself. You can call me อาจารย์ Arisara Romyen, or my nickname is อาจารย์ M. I'm come from Prince of Songkhla University. My university is located at the south part of Thailand, and I'm an alumni from PhD at Chiang Mai University as well. อาจารย์ Chu Kiat was my co-advisor, and then he very kind and very excellent in econometrics, and he always give the great advice, even in the scholar part of how to use your life. And then today is very good opportunity for me to share my experience, and we focus on the lecture today. I'm gonna talk about the introductions of data analysis for socioeconomics using STATA. I'm confident both of you. Do you know the STATA package or STATA software before? Yes. Normally, what types of statistic data that you always use or to analyze your data set? The types of statistic software. I mean, you always use the STATA. Oh yes, and then there are many kinds of STATA package. When I learn here, I have to use R program, and both of you have to use and always learn with the R program. But for this lecture, I'm gonna introduce for the STATA. Okay, let's see from content of the presentations. I'm gonna talk about research article related to a logistic model, and then just give introductions to a logistic model. And I wanna say about conduct and interpretation for a logistic regression. And then the last part, we're gonna see the demonstration of STATA tutorial in binary and multi-nominal logistic model. Okay, let's start with the research article related to a logistic model. This article was produced by me. I'm gonna tell that I'm a lecturer at the Prince of Songkhla University, and I used to survey and give like introduce or ask many farmers in particular in south part of Thailand, rubber farmer is the main production of Thailand. Do you know the rubber farmer performance here? Can everybody share your knowledge or your experience about the rubber plantation? You come to study in Thailand, and what type of perennial or cash crop is a type of the tree, right? The tree that's produced as the main economic impact in Thailand. Do you know that? Have you ever seen the rubber plantation before? No, don't know. Yes. Yes, the main economic impact in Thailand. If you look at the GDP, agriculture sector can produce or can motivate around 10% of GDP, and for the main important parts of cash crop in Thailand is about rubber plantations. Thailand is the top producer and the top exporter from rubber in the world. So I forgot to, yes, for the textile or for the growth or everything that and also the rubber wheel. Yes. So the rubber plantation is very important, and one thing about the suffer or the problem from a rubber farmer is the fluctuations of rubber price. So sometimes the price go up and peak, and immediately the price drop down. So if a farmer only focus monocrop, I mean in the land they plant only rubber, they can suffer many things because they don't have other crops to substitute or to diverse or to diversification. So my research topic is investigations of rubber plant intercropping system in the south of Thailand. I want to know a rubber farmer want to interested or look for other crops to plant or not. So I gonna set up the question research or the gap, the research question. The STATA can be used for get the information. I have question about, is data good for data analysis? You see that, as I tell everybody, major rubber export and imports of around the world, and Thailand we can do more, both even economics impact or livelihoods from many people, but the main topic is about the fluctuations of price. Okay, this is the phenomenon of our price fluctuation. You can see that in the stock price as well, the graph show very fluctuate all the time, even 3 decades or 2 decades, and also it's gonna be something like that at in the future. Almost of 90% of rubber plantation in Thailand is rely on only rubber, and then there is the rubber small holder. So if the price go down, the revenue of the households is gonna go down as well. So the monoculture is very get many problems. In particular, income risk due to the economics volatile. With the research question, as I said before, do they choose diversify their farm income by adopting intercrop system in their plan? So when I get to the field, I have to ask about rubber farmer. I mean the answer of rubber farmer gonna tell me about yes, they want to do the intercropping. Otherwise, they deny to do. So the explanatory variable, I mean the variable of y. Can everybody share with me? The dependent variable of y come from what type of this factor? About y, about y. Can everybody share with me? If I get to the field and then I ask one of rubber plantation, do you want to grow with monocrop or intercrop in your field, in your land? They have to ask me, yes, I gonna start to do the intercrop. And if they don't want, they're gonna say no. So the dependent variable of y come from with yes or no. Only two binary question. So the economic model of this study, I have to create econometric with explanatory variable of y to be yes or no. It's quite different with the continuous variable. If I ask they about income, the main income, they may answer me continuous number such as 1,000, million, thousands, or something like that. But for this case, the y come from only 1 and 0. You see that? So the econometric model, the types of model, I have to use a logistic model. Since as I say, for the dependent variable come from with 0 and 1 only. So can I use to create with the regression, the normal regression? Of course, the answer is not. That's why in this paper, I focus on a logistic model. This is the category response variable. Binary response, whether or not a person buy or some what types of example, other types of example. I can, if my research question about do you want to buy something, they decide to buy or not. So the dependent variable or y come from buy or not buy. Or if I ask about success of a medical treatment, and then the y dependent or the dependent variable of y come from so y or die as well. That means the answer gonna come up with the binary choice, just 0 or 1. And moreover, the regression, the logistic regression can extend or can expand to the ordinal response. For example, if I ask about option poll response, the variable of y come from agree, neutral, or disagree. That means then y come from with the 3 option. So the regression is not suitable for create as an econometric model. We have to use the logistic or the ordinal response. This is the criteria. Let me move a bit. Okay. For the category response variable, in this class of model, we can consider the dependent variable. As I say, for dependent variable, they're gonna say yes or no. And how can we draw the econometric model? So for the response of yes, we're gonna give them the denotations of y equal to 1. And for the answer of no, we're gonna give them answer for y equal to 0. Can everybody imagine for the next line or econometric model? The curve of the answer gonna be like straight line or the linear. This can be like that. let me share with you. Okay. Normally, when you run the regression, you can take the dependent variable to expand the independent variable x, right? To expand the dependent variable of y. And when you use the regression or the OLS, how shape of the econometric model should be? Yes, normally OLS, it should be linear, right? And for this case, if the answer should only be 0 and 1, 0 and 1, yeah, you can get that the regression model is totally not suitable with the regression. The answer of our observation rely on only 0 and 1, so most of them might gonna give the answer for yes. Sometimes they're gonna give for no, right? That shape of regression totally wrong. We want some econometric model that suits with the binary choice. That means for the category response variable. This is called Dichotomous variable. Since the answer of yes and no, the notations of yes, y equal to 1 and y for deny equal to 0. Okay, let's see that. Failure of linear regression. In case of, let me change my, okay. The dependent variable has two values. The value 1 has a probability of p, and the value of 0 has a probability of 1 minus p. Is this just the general statistics as everybody have to learn before? This is known as the Bernoulli probability distribution. So you can see that for persons from 1 until the end of your observation, if you use OLS, you're gonna receive the OLS line like a straight line here, but your observation or your answer take only 0 and 1. You see that the gray dot represent from almost of a sample size. Okay, if we use OLS, it is very error, as well as for the variant, because of the heteroscedasticity, the shape of variant not rely on the blue condition. Okay, let me see. Which function is preferred to classify the data set y as shown? For the function 1, we call this linear model. Is this not really to interpret y? You can see that the answer of observation rely on 0 or 1. So for the precise or for the precise answer, the straight line just only a little bit point that can predict or can explain or can interpretation. For the function 2, we call this polynomial model. As well as you can see the shape of the polynomial model. It is also not rely to interpret y as well. But for the third model is called logistic model. It is very precisely to interpret y, because a lot of response just point or just hit the shape of the logistic model. So far we are like gonna know what type of econometric model that suits with our gap or our research question. Okay, let's go to the next. Okay. Okay. So the logistic model is the core criteria around a problem referred to a binary distribution. This needs the applications of shape or S-shape curve, as I say. The econometric model is very good with one. It should to be the S-shaped curve like that. This is a similar cumulative distribution function or CDF of a random variable. The CDF used to represent a discrete variable are the logit or the probit model. And as you learn in your master degree, do you know for logistic and probit, like logit and probit? Have you heard before? Yes, a little bit different between logistic and probit model. For the logit model, in case of the probability of y equal to 1, the cumulative logistic distribution is expressed as here. You can see that this is the probability distribution. For the cumulative distribution functions can be written as probability of pi equal to as equation show, but I'm not gonna in depth talk about the grammarly for this cumulative distribution, since everybody gonna know well. Okay, and for the linear regression and compare with the logistic regression, you see that for the S-curve can interpret with the explanatory variable between x and y. Very good explanation. So if we use the logit model, probability functions of the logit model can represent here probability to the event of y equal to 1. Then we can ask as the econometric model like p probability of y equal to 1 equal to the equation, and probability to non-event, of course it have to minus the denied situation or the no case of this answer. So if you have time, you can take your material criteria to prove that. And in the case of logistic regression, we consider to use the odds ratio. As well. Have you used odds ratio before? No. And everyone and other master degree student here, anybody can have to use the odds ratio? Okay, let if you have time, you or if you're interested in this topic, you can try by yourself. And then we consider the odds ratio, the likelihood that an event will occur over the likelihood that event not occur. You can remember that the response or the answer of the sample size gonna give us between yes or no. So we have to determine the odds ratio, okay? And then the probability of answer for this event rely on the answer of not event. After you prove that, you gotta get the material of mathematical like I show in the slide. Let I just skip this grammarly behind them. Let everybody try by yourself. And for the odds ratio, after we take the logarithm, we're gonna get odds ratio like the regression. So we can interpret or we can create how independent variable, I mean each x, even x1, x2, or until the xn, the independent variable to expand for explanatory variable. Okay, in the case of logit model, we focus only to binary choice, I mean two alternative choice, yes or no. Furthermore, we can look at the multinomial logistic model. The alternative choice come up with more than 3 or more than 2 options. They can be 3 or 4 up on your research question. Okay, let me go to really quickly. For this, for my research, I use multinomial logistic model as well. For the dependent variable, I gonna ask them what types of crop do they prefer to do. For the one alternative, they gonna plant for perennial plants. The tree that use a long time to plant. 10 years or 15 years is quite take a very long time. Some agriculture may interested in the fruit and other may interested in vegetable. So the preferred answer of the agriculturist or farmer gonna have more than 2 alternatives. This is the types of multinomial logistic model that we can explain, or we can get the research result about many alternative answer. Okay, after I introduce or I give the background of this research, and then we can conduct and interpret a logistic regression. Okay, I show both logistic model and multinomial logistic regression. For this slide, I gonna give time for everybody to share or to ask with me again about the one. I use logistic model. The answer of Y come up with 1 if rubber farmer planters decide to operate rubber-based intercropping system in the next 5 years, and the rest of them they gonna deny. So the answer gonna be 0, meaning that is otherwise. And I ask them in deep detail about a group of rubber farmer who decide or who interested to do the intercrop. I ask them about what types of tree or what types of plant they're gonna do. So the multiple logistic regression come up with econometric model. Logit Y equal to B1 until any factor that you want to conduct. For this case, I create the dependent variable by the notation of the one. Take value of 1, as I say already. 1 refer to respondent intend to operate rubber plantation in the next 5 years. 0 if the respondent decide against the intercropping. For the independent variable, of course, the many socio or econometric economics factor, of course, direct impact the decision of those rubber farmer. I have to ask about household member, extra occupation, rubber land area, practice intercropping, and the experience for growing rubber, the knowledge of rubber. They know how they well know about the agriculture experience or practice. And the last one, I asked about attendance a rubber intercropping tutorial. Like I asked them, they used to attend some workshop or some create skill from them. This is all the independent variable that affect the decision of those rubber farmer. Okay. After I get econometric model, the methodology to investigate the variable of intercrop growth on the rubber land. The crops were divided into 3 categories. Why? Come up with 1 refer to perennial plants, 2 refer to fruit tree, and then 3 represent about home growth or vegetable. Rely on the multinomial logistic regression. In my paper, I have to present the econometric model loaded 1, and then all of them are the independent variable of many x that I have to ask them. Okay. And for the result, in this paper, I get empirical finding, decision-making factor influencing the adaptation of rubber farmer intercrop approach with the next 5 years. So the explanatory variable come from which, as I said before, around 7 or 10 factor that affect the decision of most of them. We can interpret as the, economists can interpret or can decide or can give the policy recommendation based on information only. So based on the econometric model, you can see this. We focus on the significant finding. You can see that for the star represent for significant finding, that we can confirm that if they have a lot of members in their household, they tend to do the intercropping, because the small number, they want only small revenue, so they might grow mono rubber is quite enough for those members in their household. Opposite with if they have a lot of members in their household, if they suffer with the diversify or the fluctuations of rubber price, they can survive, or they not enough revenue to pay in their household. So you can see that rely on the econometric model, you can give the confidence, or you can give the empirical finding, and then you can take the policy recommendation for policymaker to motivate or to drive the direction for improve our country. Okay, and for the deep information about what types of tree that they want to do, you can also write the econometric model, rely on the policy recommendation. You see that around 345 observations, they tend to interest for the perennial crop, around 199. For the fruit tree, they interested to do around 106. Okay, and then for the last group, they can do the growth home ground vegetable around 40 people. So as I say, when you give the policy recommendation, you have empirical finding to give the policymaker like a strong recommendation. So based on the multinomial or the logis model, you can use the econometric model to create many powerful or many precise direction. Okay, let's see for the next step how we conduct from research in the real field with them. Okay. This is all the interpretation. I can go. Okay, in the STATA tutorial in binary and multinomial logistic model, this is a package of STATA, and Ajahn Chukiat, everybody confirm that they have to use STATA, right? Yes, and then it's just a only simple regression that I gonna show.
And do you have the data?
Yes.
You have data missing.
Yes. Yes. I also prepare for data and demonstrate how to get that. I gonna take the data sets on the chat box to everybody. Let เดี๋ยวนะคะ let me give them the data set.เดี๋ยวนะคะเดี๋ยวขอสอนนี้เขาเปิดอันนี้กันค่ะวันจุดวันเยอะจังมันไปได้แล้วนะคะไหนกันนะเพราะเมื่อกี้อะไรไปแล้วนะคะ M logistic and then so far I send the data sets for all of you both on site and online. Okay, let me do the demonstrations of the data. For the observations, I take around 400. Let me see. 400 observation and a lot of independent variable that I take from this research. You can see that in the first column. In the first column, it represent about age of the rubber farmer. Status refer to marriage status. Rubber member refer to household member. Main occupations, a lot of factor you can see from my slide that I already give the notations of this. And after we already put the initial data sets, we can take the code, I mean the data code. I think I wanna take the code from all of you. Just a minute. Okay. For the cost of data rely on, I mean, related to the paper, I already text in the chat box. You can text some simple command. Okay, let me demonstrate with the data for the easy one. Okay. After we get the initial information here, we can start to do the. Okay. You see that about the observations after you type the code of this describe this kind here. You see that this kind here, the program will report the whole information of your factor. I mean, of your relevant factor. In this case, I take around 400 observation, and for the type of variable name, they're gonna report the types. For example, age, be a byte of storage type, something like that. It is depend on your research methodology. You see that it's around 10 factor that I have to survey and then to give them detail. For the summary of them, you just easy to take the code, data code, and then put in the command. After you put the tabulate, this tabulate for decision one. I mean, decision one refer to factor y. Factor y, this is my explanatory variable or dependent variable. You can see that the whole 400 rubber farmer, they decide to grow around 293, and the rest of them, around 107 rubber farmer, deny to do the rubber intercropping system. This is the reports from our initial data sets. After that, for the binary logistic model, we're gonna get the binary income. Okay. For the binary logistic model, you just take the code here. Logis, like it is very similar with the R program. For the logic type, we take the dependent variable of y. I mean, the decision one, this is my focus answer from them, and then the rest of variable refer to independent variable. After you try this, you easy to get the logis regression. But as I say before, the logis regression is very different with the OLS. We have to do for odds ratio, because odds ratio gonna compare between even that occur against with not even. How can we get the odds ratio? For the odds ratio, you can easy to get them with the data code here. Like you type logic and then decision one and the rest of them, and with the code of data here, you're gonna get the odds ratio. You see that here in the first column, when we interpret or when we do the interpretation, we have to focus the odds ratio here. Yes, this is all the logic model. And you can get the marginal effects as well. Like for the marginal effect, it is easy as well because you take the cost here. You can see that this is the margins. And for the marginal, like we divide by the x to get the 1 unit of x refer how unit to y. And after you take that, you're gonna get the marginal unit to interpret as well. If I confident if everybody have to use the marginal units to interpret any types of econometric model. And we can take the marginal unit here to interpret in our result. Okay, I go to the multinomial logistic model. Let me share the code for both of you. For the multinomial logistic model, meaning that we get more than 2 alternative outcomes. Okay. Okay. Let me get back to the For the multinomial logistic model, you can just take the STATA code as I give you. And finally, you're gonna get the marginal model from the one as well. And then you can use the odds ratio to interpret all relevant finding from your research topic. Yes. Yes, this is all the simple STATA package. Have anybody want to ask or to share with me? Please welcome your question. But I think you have to try by yourself again, and then you of course get some problems. Do you want to share with me? Oh yes, what type of data that's suitable to use? Yeah. I can say STATA can do a lot of many research area. It's quite similar with eView, but for the STATA, you can take code, yes, and then if you use eView, you can get odds ratio or marginal ratio. If you want to create some specific answer, you have to use the STATA. But STATA, like a simple regression compare with R program. R program provide advanced finding, right? But for the STATA, like immediate packet. Yes, in my view. And what about the engineering student? A master engineer. Do you have any topic to join with me? But you want to learn the big data, the MATLAB.
I think very useful and start.
Yes, yes.
I have some information from the professor in Italy. They say that the STATA is very useful for computer programming.
Yes.
Better than R.
Oh, really?
Yes.
Oh, yes.
Because the STATA is conducted or invented by the statisticians and computer science.
Yes.
Yes.
Especially
STATA,
for computer
yes,
science.
and computer science. But the R program is what is originally is invented by the statisticians. It's not computer science.
Yes.
Yeah, but that means why some algorithm in the STATA is very useful, very efficiency than the R
Yes.
programming. He told me like this. I'm
Yes.
not sure it's whatever.
Yes, whatever you
Yeah,
prefer. Yeah.
whenever we use this software, we need to focus on the this equation that we want to answer. STATA is very useful if we have the more knowledge or more option in the software. We have not more knowledge, more option to know that what is STATA can do. Now I think we have a lot of programmer
Yes.
to programming
Yes.
the package for the STATA.
Yes.
If we go to the Google, we can see many package from STATA can have the download.
Yes, free download.
The download and very useful. Normally they have the journal, STATA journal.
I see.
The STATA journal is provide many technique, right? Provide many package. If you want to learn a lot, you can join or you can go to the Google and you can search or looking for some package.
Yes.
Have the variety in the research area that we can apply. We need to know what is the research question first, and then we can use STATA to solve or to deal with in terms of data analysis or model estimation in our research area.
Yes.
I insert the code and it can run, but I try second time same code, but it's error, nothing. Doesn't mean the code is wrong or I don't know. This is the problem of mine. I have a big problem. Like I have the code, I'm so lucky, but I try second time because sometimes I forgot to save.
Yes.
Second time, but it's nothing, and then need to find another code to read this, and then try some of the code is really can wrong. So I think the code is correct and it's nice. Maybe the way that code is where I can put that direct code.
Yes, this is what you say. Normally occur with the the user who want to who rely on the packet, right? I'm aware as well when it was in PhD program. I mean PhD period. I suffer many times about the errors. Yes, and then let Ajahn Chutia or Ajahn just share.
Yeah.
Actually, actually for the application, I think you have to clear all the parameters because sometimes when you run for the second time, you got
But
another values that you need to replace, and that's why sometimes when you run for the second time, could be like this.
oh yeah.
Replace when you run it, and then it's replace the initial value of the parameters. Actually, it should be set to 0 or something like that.
Oh
But
Yeah.
you have to clear all data.
oh every time right when you oh
Yeah, that's why for my programming, I have to set like clear all data at the first to clear everything.
Nice.
Could be here.
oh yes okay for my part I think I finished with my part and then let yeah and then I gotta give it for Ajan Paramin for the MATLAB. Okay, thank you for the student in online as well. Hope to see you again. Bye. Take a break for 20 minutes and then we get back again.
Maintenance. Every business knows how hugely disruptive it can be.
this is the second part or second section. We have the okay. We have another section. This is second section. The second session you study about, or we have a workshop about the machine learning, machine learning from Associate Professor Marvin from the Songkla Technical University. It's very great tool today that we have the workshop, and then I think economists or who interest you learn a lot of things or a lot of knowledge from his experience, because he's very expert in the program about the machine learning, because normally he's very expert in the robotics programming. And today we will study about machine learning. It's very related how we can use the program to estimate or to control robot, to control some variable, to estimate some variable related with the prediction in terms of business or economy. I think it's very useful if we can learn some knowledge or some idea from his experience to help us understand more clear how we can use the MATLAB by the machine learning to estimate some or dealing with some issue that we want to understand the market movement. For example, we use machine learning to try to understand the market mechanism or customer behavior, how we can predict the customer behavior by the machine learning program. Today is very thankful to have the workshop. Let me thank Professor Marvin again to share some more later. Thank you. Very good.
Thank you very much. อาจารย์ชีเกียรติ My name is Paramin. I am a lecturer in mechanical engineering in Songkla University. And today I'm very glad to see you guys. And then my topic is like to introduce about the machine learning with you. And then I just want you to know about how to use the MATLAB to create the code for easily, just simple, not writing the code for the long lines, but just use the what we call the compact one, just an icon, just a very few short comments, few short commands to use it. Okay. This slide I made for the master and bachelor students of the mechanical, and that's why I use the topic as a prediction maintenance for the AI. AI can be used for many applications, medicals, economics, or engineering, or many applications, because it's very useful to generate the model for you. You don't need to write the rules or the codes yourself, but you just use the simple data for the historical data. You just use input and output, and you just put it in the black box, and then it will generate the model for you easily. Yeah, that is the AI. Actually, if you want to use the AI to predict something, what you have to know, as I said, the historical data is very important. Then how do you get the historical data from? You could use the sensor to collect the data. This is one of the useful applications of the predictive. And then I just want you to just keep a look on the how to use the AI for the predictive maintenance. Then after that, we are going to go to the detail of the AI. This is just simple.
Maintenance. Every business knows how hugely disruptive it can be. But AI has changed the way you can plan and schedule it. At Fujitsu, we are at the forefront of these changes, capable of processing the data sent from structural or machinery sensors faster than ever before, making it possible to monitor and predict when they may fail. The data science behind this new predictive form of maintenance has already seen us awarded first prize in a global aviation competition, with our unsupervised AI solutions scoring 93% precision. So how does it work? Our operational data management and analytics solutions analyze the vast amounts of data produced by the sensors, recording changes in temperature, noise, vibrations, whatever you need to monitor. It then forms data shapes from the flow of this information and uses topological data analysis technology to learn what normal looks like. If that shape changes or an unknown state is spotted, it indicates an anomaly that may require timely intervention to avoid any imminent failure. Even if you're new to predictive maintenance, we can help immediately. With insufficient data, our wide learning technology creates hypotheses to test against, so your data repository is developed more quickly and anomalies can be identified. Whatever you need to maintain, it's time to stop spending excess on replacement parts, to stop relying on misleading fault diagnosis, to stop any unnecessary maintenance downtime. It's time to start predicting your maintenance with AI, to start saving time and money so you can expand your capabilities. It's time.
Yeah, as it says, it uses all managed data to use as a data and then put it into the model, and then you can predict whether the part, the mechanical part, whether it's failed or not, something like that. This can be used not only the mechanical, but it can use many applications. For today, I have one example of the medical data, and then we will go through it later. Okay, this is the definitions of the artificial intelligence. The artificial intelligence, or AI, is the simulation of a human intelligent process. That means it allows the robot or the computer to think rationally or think with the reasons. It's like we have the logic. If we are talking like things like the logic or logically thinking. It's like we have the sequence with the reasons to think about, like the human does. This we can use many applications for the AI. For example, in the expert system, we can use it expert system, natural language processing, speech recognition, or machine vision. Many applications that we can use the AI in the robot. I just want you to see some let me check it. This one. This is the robot that I did Dongyang University, Dongyang team from Newcastle, from PSU, from Prince of Songkla University. Actually, when the robot, if you want the robot to grasp the bottom of the water, you should teach the robot, or you just develop the algorithm of the AI to detect the object first. It's like what we call the classification of the object. That means you have the robot should classify any kinds of the objects. Once the robot spot on the bottom, and then it has to calculate the centroid of the object and then grab it easily, something like this. And then it has to go to another room. That means you have to know the map of the room, and then the path of the movement as well. something like this. This is what we use the AI. And then even the speech recognition. When you ask the robot to grasp the bottle of water, the water, you just say, "Hey, Java, you could go to grab the bottle of water to me," something like this. It's used the speech recognition, and this is the AI. Okay, AI is like is very, it has a lot of things to do. For example, it has machine learning for the predictive analysis. It has the speech recognition, as I said before, and then it has a vision to classify the objects, something like, or language processing, exposition, path planning and optimization. Robots. This is a AI can be used in many applications, even in a medical, as I said, to use to detect the. For example, my colleague working on the doctor to use the figures on the lung, and then to see whether the lung is failure or not. To just use the pictures of the lungs. And this is how the AI to apply for the robotics nowadays. And this is even the
If you think you are tired of your everyday
automatics is now also use the AI to detect the objects or detect the force or anything. Many things can use for the AI now. Even the robot, this is for the highlight for the AI, I think. There are many.
Despite taking people's jobs, robots have been proven to be
AIs for self-balancing or grabbing the objects, how to grab it optimally, just put it into some place or underwater. Robots, many kinds of robots, and also use the AI. Okay, this is the AI. We have the big one, what we call the AI artificial. AI is like the programs that you program to be ability to learn the lesson of the human, just working on the some task. This is the AI. But if you have the AI and then you have the data to config, to design the model for you, what we call the machine learning. But and then, as we know now, the computers has been developed for the high performance, and then we could use the neural network. This is one of the AI. And this, if you use neural network to create the model, for you don't need to do with the pre-processing, something like this. You can use the deep learning. You just put the all data that you get. You don't need to pre-processing it. Then you just put it into the neural network. It will generate for you. That is what we call deep learning. It's the subset of the machine learning, and machine learning is a subset of the AI. This is, but I just you to know just slightly. But I don't want to go for the deep detail of the AI. This is, and today I'm going to talk about the machine learning. Machine learning is the subset of AI, as I said. It's used the statistics and the mathematics to generate the model. And today we will generate the model of the neural network, and then I have two models for you to learn of the machine learning. I have the neural network. It's like the model is imitate the human brain to think. It has the layer of the neural. It's like the human brain, something like this. This is why what we call the neural network. And then another one is what we call the support vector machine. I will let you know later. this is the traditional program. What the difference between the traditional program and machine learning? Actually, when you program technically, you will have the data and then you program it, right? You program to the computer using C, Java, or Python, or something like this. You program it. This is what we call the traditional, and then you will get the output. This is the traditional. But for the machine learning, it's totally different because the input of the computer is the data and the output, the data of the input and output. And then when you put it to the computer, finally you get the model, or let's say programming, get a program. And after that, you use this program or this model to predict something that you want. For example, you could use in economics, you can estimate anything, not really in economics. But for me, I did the research on how to estimate the human pushing force by hand. Then what I have done, I just collect the EMG. EMG is what we call the electromyography. It's the electric generated by the muscle. And then we can collect the data, and then we can estimate the pushing force, something like this. This is, I will show you later. This is what's the difference between machine learning and traditional. Yeah, it is. If you're talking about the AI, that means you adjust the rules by yourself or using the data. You could use the data, you could use the human to do this, what we call the AI, to correct the rules. And then after that, you solve the problem. And then after you solve, you evaluate what the rules that you have done, whether it should be corrected or improved. Then, but if you use the machine learning, you don't need to write your code yourself. You could use the data here that I said. The data, put the data to train the model. Once you get the model, you can evaluate the model that you have generated from the data. Okay? And then if you appreciate with the model, you could use this model to predict what you want. Okay? Then this is the type of the machine learning. Machine learning has 4 types. For the first one, what we call the supervised learning, unsupervised learning, reinforcement learning, and imitation learning. Okay. We're going to see what the difference is among those. Okay. For the first one, what we call the supervised learning, it's like learn to label. It's learn to label. It's like when you were young, you learn from this is the apple, this is the lamb, from what? From the color, from shape, or something like this. And then this is, if you see this model, it's like what you learned from when you were young. You could use the color to categorize the apple, a lamb. And then what you have to do is just put many figures, many pictures of the apples in many actions, from the bottom, from the size of from the top. You have to capture many angles of the apple, and after that you put all set of pictures into the model, and you say that this is apple. That I said, you have to label. You have to label. You have to say that this is what that you want to teach. And another one, if you say clean, okay, you use the lamb. Okay. And after that, when you use it, and then when the model generated, you could have the model. And after that, what you have to do next, you just use this model to predict the input. For example, I have this picture, and then I put this picture into the model, and then the model will calculate everything, and then it said that this could be lamb. 85% of the confidence. That means It has a confidence of 85% unseen object. Why is it unseen? Because this model never seen this figure before. Technically, when we teach, when we train the model, for example, we have 100 samples. We separate it to groups, around 70% and 30% for testing, 70% for training. And after that, if you want to evaluate the model, you could use the 30% left to test. This is what we call the sample. This is what we have done, what we call the classifier. It's like we classify between the apple and the lamb. Sometimes if you look at this is a green apple, but it's classified as the lamb. Is incorrect. It's incorrect. Yeah, that's why I said that once you create the model to classify something, you could have something is not 100%. It could have is lower than that. Okay, this is when we train it, we have to use many kinds of data. If you had get higher or a lot of data, you could have the higher of the prediction percentage. For the first one, supervisor, that means you have the label. You label the thing that you teach. For the second one, you don't have any label. Unsupervised learning. That means you don't know what it is, but you have to classify it. You have to classify it. How should you classify? What you have to do, you have to learn from the similarities and the difference. What does it mean? You have to find the similarity of the groups. For example, you have the fruit, many kind of fruits, and then what you have to do, you have to get the similarity of all of them and the difference of all of them. And then you try to think about what the group of this. It's said that you have to separate it with the unlabeled objects. That means you don't have the label. You don't need to tell the robot, this is a cake, this is a meat, steak, or something like that. You don't need to label it. You just put the figure of this one and put this one. And then what the criteria that should separate these? He said that intra-group similarity should be high. That means if you have the same group, the similarity should be high. But if the different group, or let's say inter-group, is different, the difference should be high and the similarity should be low. This is the axis that we want to plot it, to separate it. We said that this is the percent of the sugar contained, and this is the percent of meat contained. And then you plot it. For the steak, the sugar is quite low. For the meat, it's quite high. You plot here. And this is spaghetti or something like this. You just plot here. This is the cake. This is the cupcake, or is contained with the high sugar. It should be around here. And then meat is very low. It should be here. If you look at here, we have to separate group. This you can distinguish for two groups, but you have the intersection. If you look at here, this is the dessert called crepe in Thai, crepe. And then in crepe, we have like this is what we classify as the sweet, but or the dessert, but it has the bacon, the meat. That's why some could classify this as what we call the meat group. And then this is totally what we call intersections between both groups. What we decide on this one, what you have to do is you have to find the centroid of the groups. Group 1, group 2, you have the centroid. And after that, you find this one. For this group, for example, this is a grape. You just find the distance between the centroid, two centroid. Which one closer? You just select that. Something like this. This is what we call the unsupervised for classification. For the first one, we call supervised, and this for the second one for the unsupervised. I will show you some video for the YOLO that some people done, but my study or working on this one as well using YOLO to detect the human. This is what we call the classification for the first topic that I said. Supervised learning. You know, once they use this one, they take the photos for many objects, including humans, cars, or motorcycles, or anything. They just put it into the model with the label that I said. It's like supervise. You supervise, like your supervisor teach you how to do something like this. You teach the robot to do something like this. You have to classify. This is the human. If you look at here closely, you will see a baggage, persons, trunk, car, something like this. This is the robot classified for you using the what we call the supervised learning. Okay, this is for the first one. This is actually for the class.
Okay, so now that you know a lot about representation learning, I want to move on to discussing a particular.
Sorry. Okay. For this one, it's done by the master mechatronics students. It's used the EMG, as I said, electromyography, to estimate the figure of the human palm. It's closed or open or rest, and then after that send the signal to the robotics arm, and then to grab the object. This is what we call the AI. It's use the label as well. Once you close the hand, you measure. When you close the hand, you measure all of the EMGs or here attached to the muscle, and then you use signal with the label, close or open, something like that. And you teach the model, and then after that, once you get the model, you just use the model and receive the sensor from here to estimate the human hand figure, and then you just send to the robot. That's it. This is for the second one. For the third one, this is for the regression. This is for the regression. This is a rehabilitation to estimate the human force acting to this one, and use the EMG pushing the robot by playing the game. Something like this. We can estimate the force by using the EMG. This is the regression, not the classification. If classification, you just say that this is open hand, this is closed hand. But for this one, you can estimate the force. How much force that you apply to the robot is the continuous signal. That's why I said that we use the regression for the robots. Regression AI. Okay. This is for, can you guess? This is classifications or by using the supervised or unsupervised.
ระบบตรวจสอบใบหน้าสำหรับเปิด
This one, they use the face recognition to open the door. Can you guess what kind of supervised or unsupervised AI that used in the project? Supervised or unsupervised? Unsupervised. Next. Anybody? Unsupervised or supervised? You have to think about when you want to access the door at the dome at the university, you have to recognize first, right? You recognize that guy, and then you have to check that guy is allowed and authorized or not. That's why when you see the figure or you see the face, you have to know who is him, who is this guy. That means you have to got the label. You have to know, you have the badge of the name of that guy, and then you can know this guy authorized to come to the room or not. Okay, that's why this situation we have to use supervised, because if you use unsupervised, you don't know what's this guy, but you know this is the face. But if you want to allow this guy to come to the room, you have to know who is it. He is the student. Okay, it's allowed. Yeah, this is the bachelor degrees to do this one to detect the human face, something like this. Here, and then the door is open, you can come. And another one, if you don't wearing the mask, the door is closed. But if you do not, but if you wear it, it turns to green, and then you can go to the room. The photo. In this one, if the photo we try it, but it's not detected. You have to, because in my system I use what we call the pipeline to detect the human skeleton first. If you not see the human skeleton, it cannot go to the next step. It's have to check the human. But if you use the paper and you do something like this, it's still working. This is what we call it's not working 100%.
How we can develop more clever of AI?
Yeah.
How we can
This is
tell them to how we can let them get more underlying deeply, because of when we have
the paper to cover this one.
cover
It's
mouth,
still working.
and how we can develop. How we
Actually,
can let the AI more clever.
Yeah. This is what we have done as well now. We have been doing on this topic. We capture the many kind of fake mask, face wearing mask, and then we put it into the machine learning and say that this is fake. For example, if you have to see the hand of the human like this, because in the model we can track the human bones, many joints, all of the joints of human, and then we can know the pattern of the hand. If the hand is up right here, we said that it's fake, something like that. This is just, but it's not working 100%. We try to figure out.
Let them more clever.
Yeah. This is, as I said, we have to get more information, more data. We have to put more and more. And then you say that this is fake, you're not allowed. Something like that. You have to put many type of, or you say something like this, you do something like take photos, teach them. Yeah. The more data, the clever is it. Something like that. This is like the human. This is what we have done is to use the stimulation head. We're working with the medical, and then use the what we call the like magnetic wave to stimulate the brain of the human. But what we have to do is to detect the human face. Yeah, we also use AI to detect the human face, and the robot will go to the point that you said. If the human, if the head move, the robot should move, comply to the movement of this one. Okay, this is how to use the robot to detect the human, and then go to send to pass the object to the human naturally. Just look at here. Also use the AI. This is for the master. We use the what we call the human hand configurations to control the robot. What we call hand gesture control the robot. If you look at here, this is the hand gesture control. Use the hand. This is the capture by the camera. Use the AI to detect the position. Like it. Okay. Okay. We move back to the supervised, unsupervised, and then another one is what we call the reinforcement learning. This is like learn by trial and error. Is if you, for example, if you see the rat in the mess, something like this. If you go to the right path, or if you got the corrections, you will get the reward. But if you go to the wrong direction, you get the punishment. It's like our parents teach us, right? When you get the reward, you will remember, okay, if you go to this way, you got the reward. And then you have to go further to get the reward. But if you go to the wrong direction, you have to think about and then do it again. Finally, you have to get the what we call the highest score of this. And then once you get the highest score, you will get the policy. What is the policy? Policy is the sequence of the action that the robot should do. It's like you have the plan to go. If you see the problem like this, you have to go like this. If you go like this, you will get the reward. You get the highest the reward. That is the goal of the reinforcement learning. Learn something. I have to show you some video of the Mario playing. Let me show. Here.
The neural network you're seeing is a pretty complicated one, and it got so complicated as a result.
This is Mario. Mario will play. This is controlled by the robot. You know, the robot play the joystick, not using the computer as a robot. The robot play the joystick mechanically. Then what it has done is play thousands of times or millions of times, because its goal tradition is go in this way, it's got the highest score. It's go to this way, you punish something like this. The robot will learn. And then if you look at here, this is the way that the robot have done before. The robot have to learn to select which path that go to with the highest strength, highest reward. And this play itself. If you say A, B, X, Y, up, down, left, right, this is the joystick button, and the robot presses it. Yeah, this is or use reinforcement system. Okay. Okay, for the last one, what we call the imitation learning. Imitation learning is the subset of the reinforcement of this one. Of the reinforcement learning is a subset of this one. This one what is like imitating learning. You have, it's like, for example, I have the robot. The robot will learn how to, for example, it's driving the car. The robot is like the robot sits beside you. Actually, it uses the camera to detect what the react of the human, what the human behaviors once it has the car in front of you in 50, and then you drive with the 51 kilometer per second or something, kilometer per hour. What it should do is the situation like this, something like this, the robot will capture all reactions of the human, and then it will generate, and then it will drive the car itself. For example, in this one.
And high-level commands such as turn right at the next intersection.
You go, and then they can learn many times, and then after that it can decide whether it's go to which direction. This is a simulation. What the car should do is go. This is for the simulations, and then it's real. Yeah. This is run by the robot. So go to this section. It's go to the left or to the right or something like this. It's learn itself by seeing the, or let's say indicating for the human. Okay. Okay. It took around 30 minutes for introduction of the AI. And then I think it's time for introducing MATLAB. Okay. Actually, I'm going to talk about the MATLAB. How to use MATLAB to generate the AI or the machine learning. Today, I'm going to use just let's say one technique is very easy to use. You just call the command and then you just put the data. I will show you how to use it. Okay. If you have the MATLAB into your laptop or your computers, it's better if you could go to the MATLAB and then follow my instructions. Then I also have the file in the, if you go to the chat box, you will see the link for the all resources that I have put it here, all resources to use for today. And then if you have the time, you can go and then learning by step by step using this one, what we call MATLAB exercise. If you go to the MATLAB exercise, you can see many instructions that I said for the symbol. Here, you can follow the instruction and you get the data. I already put this file that used to the simulation. Okay, you got it? Okay, okay, then if you go to this page, this is what we call the use for M file. Use file to, you can drive here and then you can run it. Or if you want to run code line by line, you could use the command window. For example, if I want to say X is equivalent, you can use like this. Y equivalent X plus Y, you can say something like this. You can use this symbol. Or if you use the M5, you can say, okay, you say X equal 1, and don't forget the command, this side, semicolon, yeah. And then Y equal 1 for 2, let's say. And then if you want to know C equal X plus Y, you want to know this one, you click run. You click run. Just waiting for this. Have I click it? Okay. Click and then it says C equal 3. Something like this. This is for the MATLAB, for the symbol thing. You can see in the workspace here. The workspace is shown by the values that you put in the parameters. For example, in this you have X equal 1, and you see this one, X equal value is 1, Y equal 2, something like this. These are the parameters and the value. That's why I said that once you program on any kind of programs, what you have to do first, you have to to clear all data. Perhaps you have 2-3 programs run together. It could interfere each other if you use the same parameters, something like this. This is what I said. What you have to do, you have to clear this one first. Okay. This is for the simple one. Okay. What I have to do, I just want to clear all of this. First, clear. You can use CLC and then clear all. Or you can use CLC like this. CLC in the command window and then clear all. Here, it's all clear. You have, okay, you have to download this file first, the file of this one. Could you download first? Copy of T-Data 2. You right click and then you download here. You download. Okay. Download to anywhere into your computer. This is, I'm going to show you, I have the medical data. This is quite secret. Then it's got a lot of data. I will show you. Okay, I'm going to, have you download yet? Okay, once you download already, you go to open. You open that file first. It's like we are going to load the file to the workspace. What you have to do, just going to open the file that you store. You open the file that you download. It's XLS. Okay, the surname is XLS. You can open in MATLAB for the Excel files. You can open in MATLAB. Okay. Once, okay, just waiting. Once you click open, it will show you this window, right? What you have to do, you just import here, import to this session, import the selected data into the MATLAB workspace. You just click this one. If you done correctly, if you check to the workspace, you will see that file into your workspace. You can close it after you have seen the copy of data. If you cannot follow me, you don't worry. You just read the instruction that I gave you. For sure you can do it easily. I have this, and then I have the many kind of exercise, but unfortunately today we don't have much more time. Then I just select one of the exercise that I have that I think is very easy for you to modify this for your work or in the future. Okay, I'm going to open this and then I import this to the workspace. Have you done? If you want to know the data, you could double click on this one and you can see the variables here, and you can see all data contained in the file. It consists of the partition count, F, D, S, HN, the number of the HN, the time, the sex, the age, the body weight, the BMI, the heart pulse, the beat, or many kind of parameters in here. If you look at here, but I'm not expert in the medical data. Then I just know just few of them: the strength, the quality, the code. This is the pills that they use, the medicine that they have to use. Okay. Once we have all data, something like this, we want to, firstly, you have to think about what kind of the class that you want to predict. The class is the, if you think about the label, this is the label that what you want to, for example, you want to know about the difference between the apple and the lamb. That means you want to know the class is the type of the foods, the fruit. Okay. In this, once you're done on this one, you get the data in the workspace already. What you have to do next for the easy, you just click classifier. We call the classifier here. The classification learners. You click here. Classification learning. Just learning. You have the capital L. Just only learning. You have to put the capital L. Classification learner. Okay. Classification learning. I put here into the here classification learner and enter. Okay. Just waiting for the window. Just waiting for it. It's very easy. You don't need to write the code of the classifiers. For example, if you want to use the artificial intelligence, artificial neural network or support vector machine, this is the kind of machine learning that you can use for the classification. In this case, you don't need to write the code. You just select it because it has the what we call the default value. But if you want to change some value, you can do it by writing the code. But that type is quite a little bit difficult. Okay, once you get this window, you have to import the data that you have. Where you have it? You have it into from the workspace. That you put it. And then if you have the data in the workspace, it will generate it for you automatically. Okay. If you look at here, step 1, you select if you have more data, more sets of data, you can select the data that you want, set of data that you want. And after that, if you look at here, there are many kind of parameters in here, the parameters. And then what kind of the class or what kind of the value that you want to predict, you can use it. For example, in my case, I want to use the gender, the sex, this one. I want to use the gender to, and then what you have to do, you have to use this, you have to select for the response for the class, for the output. Let's say easily the output. You want to predict the gender of the pattern. Okay, you use this one, and the rest are the parameters, right? And then what you have to do, you go for the start section. You go for the start section. Okay. Okay. For this, I want to introduce you about this one, what we call the parameters relation. You can see how the parameters relate to each data. For example, I want to plot x and y. What I want to know about the age. If you select age for the x-axis, I want to see the relation between the age and the heartbeat or the pulse. Let's say I select age and the heartbeat, let's say pulse. I want to see the heartbeat and pulse. You can see the relation on this by doing nothing. You just click it and then you can see the relation. If you see this one, you can know the age between 37 to 45. The heartbeat could be around lower than 80, for example. The average should be here. But if you have the average around 51 or 51 to 56, the average of heartbeat should be around more than, it's around 85 or something like that. You can see how the heartbeat relate to the age of the human. Okay, this is, or if you want to know the body weight, if we want to know about the body weight of the patient and pulse, what the relation between this? If you look at here, body weight here, this is the body weight of the patient, 59 kilograms to 85 kilograms, and you can see this. The more body weight, the higher pulse, right? You can see like very different. This is just very simple because you can see how relate between two parameters in this way. This is quite basic. And then, okay, once you know about the relations, after that, you want to create the model. You have the data already. Now you have the data to predict. Is the data for prediction is the gender, the sex, right? And then the rest of the parameters are the input variables. What you have to do is just click here. Click here. Click in here, in this here. Click down, and you will see many kinds of classifiers that you can use. This is one of the AI and very popular as well, what we call decision tree. Decision tree is like it's used the binary question to ask yes or no, and then go further for the next. You like to write the tree go together. What we call it, decision tree. This one. Could I go for decision tree? It's like this. Use the questions like yes or no to categorize many things, something like this. This is what we call decision tree. I talked to you previously, support vector machine. This one. Support vector machine is like, I will show you. Support vector machine. Support vector machine is used to separate groups. Okay, it generates like right here the boundaries or the line to separate both of the group. And then this is the what we call support vector machine. Okay, this is support vector machine. You can select it as well. You can use K-length, A-length, neural network, anything. But for me, I'm just going to for the simple one first. I'm going to talk about it. But for you, you can select any kinds of classifiers that you want to use. For me, I use all trees. First, you see this one, all trees. You click it. Once you click it, it will show to here. All three is will show here. All trees. Now we are going to establish the model of the trees by using that data. What you have to do, you have to train it and then it will generate for you. But if you use the classification learner, just one click to get it, train, click it. Just click create, and then it will generate. Just waiting for the result. It will show you how accuracy it is as well of the model, the trained model. I mean, just waiting. It could take for a while. Not too much long. Around. You can select many kind of this is alien. Oh, sorry. This is the ANN, what we call artificial neural network. This is kind of the AI classifier, or let's say machine learning classifier. It's very popular. It imitate the human brains. It's like we have the cells, and this is present to the brain cell. Not finished yet. Just here. If you look at here, it's done. It show me it's got the accuracy of 100%. That means if you use this model to classify the sex, male or female, it's got the 100% of the prediction. Okay, I'm going to use another one. I will use linear support vector machine. I just want to know if I use the linear support vector machine. And then if you want to know, just click here, try it again, train it again. Something like it's got 64%. It's lower than the 3. Because some model suitable for some classifiers. Okay, just try it. I will let you try on this one, and then I will go for how we export this one to the workspace. Just have a quick look on this one. This is very important for you as well. Once you know the accuracy of the model evaluation, you can go to the confusion metric here. Click the confusion metric here, and you will see some results. if I go for the first model, if you look at here, how to interpret the metric. If you look at here, the x-axis show the predict class. The class is like the output, let us say. And this is the true class. I predict 2, and the true class is 2 altogether, 19. That means it's correct 19 for the, if I predict 2. Okay, 2, that means for female, let's say this is male. If I predict female and then the true class is female, okay, 19. This one I predict male and this is the true is male. We got 35. That means all we have correct one. But if you look at the support vector machine here, the system predict as the predict class is 1 and the real is 1 as well, is 35, but it predict 1, but actually that is true, or let's say predict male but is female. 19 is wrong prediction. That's why it got only 64%. This is technically once we want to know the performance of the model, we use the confusion method to see. If you look at here, if the diagonal squares, that means you are correct. The prediction is correct. But if this one out of the diagonal here is wrong, if you look at here, if in this diagonal, okay, is correct, but this one out of the diagonal is wrong. That means it's not good, something like this. Okay. Okay. Then after that, once you finish this one, you export. You right click here. Just wait. We want to export this one. How to export this one? Sorry. You click export model here. It asks you about the export file that you want. You want to export to the workspace, right? Yes. What's the name of the model that you want to use? Yeah, you can write. Maybe you can use your name or any. This is the train model that you got from the train, right? For example, I select this one 3, and then I want to export. I said, okay, train 3. That's simple. Okay, we got export. If you go here, train 3. We export to the workshop, sorry, workspace, and then that means you have to see the workspace here. If you want to know the detail of this, you just double click it. It will show you the classification, the required values, or you use classification trees or many things. Here, the details of the trained model. Okay. Then now, okay, technically you have the data. You put the data to the model. You got the model, right? Now we export the model to the workspace. And then the next question is, how can we use this model to predict our data? How can we do that? What you have to do, we are going to create the input for the model. We are going to create the input for the model. Okay. the easy way to use it by we don't need to create the value like this. What we have done just we duplicate this one first. We use this is the data, right? That we have 54 by 28. That means in row we have 54 rows or 54. You can see this one, 54 rows, right? And then you have data by 28 columns. Row is 54 and column is 28. This is the structure of the copy data file that you have. Okay. Then what I have to do is just duplicate. Just want to copy this for another one. Just click it, and then you will get the duplicate file. Okay. Just right click and duplicate it, and you will get this file. Okay. You check on the workspace. What you have is three kinds of data. The first one, file, and this one, the copy file and the train model. Okay. After that, we want to generate the input file. What you have to do? Can you write here like this? Copy file data, the one that you copy, I mean the duplicate one. And then this command presents 3 to end the row from 3 to end 3 to 54 equal the empty set. That means we want to delete the file, delete the data from the third row. So to 54. Okay, I will give you the command in the chat. Okay, just write it, and then for me, I'm going to write here. Okay. Write the command. If you look at here, 3 to n means we select the row from 3 to n, 3 to 54. And then this command means all columns equal set one equal empty set. Okay. And then what you have now, the copy data changed from 54 to just 2 lines. This simulates the input that you have in your hand, and we want to put this into the model, and then we want to check it whether it's correct or not. Okay. Now we have the data already for the input. Actually, you can get this one from the data, the new data that you collect. You know what I mean? The data can be separated into 2 groups. For the first one, for the train data around 30%, and then 30% for evaluation of the model. Then once we have this one, we want to use this as the input of the model. What we have done, you just write this one. I just want to take this one to t, just variable t equal this one. This one is very, you don't need to do this one. But if you want, just say this, I will put this into t variable. Put all the copy file to, not copy file, the copy file that we modified already. And then we put it into the T. And after that, you can see this one. If you click here, train 3, you can read this one. The variable have been created in the workspace. That means the data, the train data. The train 3 is already done. And after that, if you want to use the model, you just write this line, just one line. Just one line, you can get the output. Y fit equal train 3. Train 3 is this one. Predict function T. T is the value that we put in here. We can copy this one. And when we put here, and then we run. Once we run this one, once we run this, that means the input that we have, let's say, let's call, this is the input T. This is the input. Two rows. And then we want to predict the sex here. Sex represented by 1 could be human, could be men, something like this. And then the output from the train model, we get 1 and 1. This is 100% correct. Okay, I will summarize again. For the first one, you have the data. Okay, you have the data, and then after that, you put the data to the classifier learner, and then you select the type of the classifiers. There are many types of the classifiers. Artificial neural network, support vector machine, tree, logistic regression, support vector, KNN, many kind of classifiers. You can use the linear, quadratic, linear, something like this. Many things that when you once you select it, you click just one for training. The train is the process of your data, using the data into to find out the model. And after that, you get the model. What you have to do next, you can read the accuracy of the model. And after that, once you're happy with the model, any kind of model that you want, you select it and you export it. Once you export it, it will show in the workspace. And after that, what you have to do, you have to generate the input to check it, because you have the model already. You just use the input into the model. Okay, and then finally you will have the output from the prediction. As I said in here, like this, we have the data, we have the output here, train, and after that, once we generate the model here, we just put the data, it will show the output easily. Finally, you get the output from here, and after that, you will check it correct or not, something like this. This is the model that you have here. You just write one line. This is quite simple and easy. You can compare between trees and support vector machine or any kind of thing. This is just very few techniques that I teach you. But if you want to design your own classifier, for example, if you want to adjust the parameters of the tree of the AN, you can use another function. This one is quite easy for the complex one. Okay. This one, we use the support vector machine to estimate, but you can go and then run step by step and see what happened with your result. Then you can know here. If you want to train, you just use one line to train this one. Use the support vector machine to train, and then you can get the output. One day you get the output, you can calculate the accuracy or anything, and then you can use for prediction as well. You just use pre and then model and then you value that. It is quite simple. I have done some papers on MATLAB as well. Yeah, this one for this one we just under review. We use the EMG to estimate the human internal muscle resistance, because once a human acting like this, it has the resistant force acting against the movement. Even we don't apply any external force, but it has internal generated by the muscle. Then we estimate the muscle of the here. We estimate the dynamic muscle estimation for the robot. And then this we have the model, and then we file out the support vector machine and artificial neural network to generate, and then estimate and compare with both of them. This is for the result, and then you get some. This is the actual, and this is the estimate one. It's close to that one. And this one we have the pushing force here, pushing or pulling force acting by the handle. And then we also estimate the relation between both of them. EMG-based force estimation using dynamic contractions in the physical human robot interaction. This is another work that's done by the master student. And we are quite close to the estimation. Then this one, we estimate the parameters. We have the model of the robot acting with the human, something like this, and then we have the equation on the. Yeah, this is a simulation transfer function, and then but it's quite very complicated. Not quite, it's very complicated, and then we estimate it using the AI Max to, and then we use the AI to estimate ABC and to generate the transfer function. Finally, we have the transfer function, and then we get we compare with the actual, and then the result for simulation. Quite good. And the last one, we have the AI to estimate the human that I told you, to the human skeleton and the position of the human hand, because the robot has to move and then pass the object to the human correctly. Yeah, something like this. It has to calculate the human toes and then hand or something like this. The position. We have the metric of this one, and then we have transformation metric. Then we done this. Move it. Okay. This is just few applications that I have done. And then today I think I can share with you. If you want more information, you could contact me directly, or even in the internet or YouTube. Many things have a lot of tutorial class. I think nowadays we can learn by ourselves using the YouTube class, something like this. Okay. Thank you very much for joining today, and then thank you, Ajahn Sukiat, that invite me I very honored to come here. Thank you very much. นี่ก็
Thank you.
Yep, I will send it.
Download man
Yeah.
data or everything.
Yeah.
Understand more about it. So why learning, like I'm so one learning, reinforcement.
Immediately. It's like the subset of the reinforcement.
Yeah,
Yeah.
first time in this class. Okay, any question on things? Okay.
Thank you. Okay, thank you very much. Thank you.